All right, line P1, learning task 12c. We are going to take a look at the third of our transformers over here. And this is going to be the same 15 kVA transformer. We're going to go make an autotransformer connection, meaning an electrical connection from a high side to a low side. And we are going to feed in with 120 volts at this point. What we can do is we can start by redrawing that circuit that we have. So if we go and take this section over here, the 120, we see that's going to be my primary section over here, that 120. I see the X1 of that connects over to my H2. And so I just draw that connection all the way across like this. And at that point, we have got a standard looking autotransformer. We also note that my polarities are going to be seen as being an 80 type of polarity. Right? If I take a look at this, I could assign any sort of a polarity to X1 or to H1. It really wouldn't matter which I would be. But whatever I have, if this is going to be a positive here and a negative here, that would mean that this would have to be a positive, which would mean that this would have to be a positive over here as well. And if this is a positive, this would have to be the negative. This over here is going to have to go and be the negative as well. So we would go and see that we have got positive, negative going into positive, negative. We refer to that as a series aiding type of configuration, which is more commonly going to be inside of transformers referred to as a boosting type of configuration. They go through and do the instantaneous polarities on the actual drawing there. They start by freezing the sine wave that they have coming in there, my AC 120 volts. They're going to freeze that thing at this point where this is negative, this is positive. And when they do that, then they go and instantly carry this over here to become a negative as well. We need to go and have that value in there that's going to be the same. From there, I then transfer these lines all the way through. And if I take a look at it, I've got 120 volts, and then I'm going to go and series into another 600 volts. That is going to be an aiding type of configuration. If I were to look at it, it's a 120 volts in series with 600 volts, which is bringing us back out to an earlier voltage we examined, which was 720 volts over here. That is going to go and be my maximum amount of voltage that I could go and pull out of this transformer connection. Perfect. If we know the maximum amount of voltage, we should also be able to figure out the maximum amount of current. If I take a look at my windings, I see that all my current is always going to have to flow through that winding. Therefore, that winding is going to be seen as my limiting factor. Going back to this thing as a 15 kVA transformer, we knew that this was rated for 25 amps. That's the gauge of wire that we were used inside of here, because that was a 15 kVA, which means that 25 amps would be the maximum we could pass through it, and therefore 25 amperes is going to be my maximum that I could go and deliver out at that load over there. What does that give us for total amount of power out? Well, we just take our volts, we multiply them by our amps. It's going to go and give us our VA, 720, multiplied by 25, which is going to go and give you a grand total of 18 kVA that we are going to have out of it. Let's go and take a look at our currents that we are going to have inside of here as well. If this is 720 volts and 25 amps and 18 kVA over here, then this must also be 18 kVA. kVA in is always going to be equal to my kVA back out of this one. So I take 18,000 over here, and I'm going to go and divide it by 120 volts. When I do that, I find out that I'm going to have a line current of 150 amperes. Perfect. So now we know the amount of amps that I have inside of here. We know the amount of amps that I have here and here as well. The rest of this is now just going and tying these things together and then sorting out what we have for sourcing versus sinking. Once again, can both sides of my transformer be loads, or both sides of my transformers be sources at the same time? Absolutely not. One is going to be a load, one is going to go and be a source. Let's start by taking a look at our load. We see that this load is connected over here to what is positive. Therefore, this end of the load would have to be positive as well, which means that the opposite end of the load has to be a negative. And if this is our ultimate load over here, we know that current needs to travel through from negative to positive. So I'm going to have current that's going to travel through up to there. That would mean that that current would have ultimately come out from here and then traveled through here, traveled through here, traveled all the way through the load back up into there. What magnitude is it? 125 amps that I have over here. Secondly, when I take a look at my source is going to be delivering in 150 over here. So I've got 150 in. Then I'm splitting off with 25 over here, which means that in order to satisfy Kirchhoff's law of current, I must have another 125 that is then going to go in through here, right? 150 splits into 25 and 125. That 125 comes through here, joins up with that 25, and here's my 25, and together exits this transformer as 150 amps over here. It's fantastic. Kirchhoff's law of current works out for us. Let's just go and examine the directions of current that we have going through these two windings right now. Just erase a bunch of other stuff inside of here, just that we are looking only at those two. When I take a look at these, I see that this current travels through from positive to negative, which tells me that this must be acting as a source, this winding at this point. It's becoming a source. This one over here is going to have to act as a load, right? We cannot have two sources. We cannot have two loads. So this one is going to have current that is going to go and travel through from negative to positive. It's acting as a load. All right, let's carry those values up top to this one. So at this point now, we have got a connection. I don't know if actually we defined that. We'll just go back down to this one here. We didn't define if this was bucking or boosting, but if I take a look at what I'm putting in, 120, and what I'm getting out, I see that it's the sum of those two. Therefore, I know that they're aiding each other. Therefore, I know that this thing has to be a boosting type of configuration. Let's write that over here. We know what value of voltage we are able to go and get out of it, 720 volts. We know our current that we can go and put through that, 25 amps. We know our kVA, 18 kVA that we have. Last thing that we need to define is the applications that step up or step down. Well, we see we got 120 in, we're getting 720 back out. So this is going to be a boosting step up type of configuration over here. All right. That is the end of this one. They're progressively getting shorter. The first one's the most explanation. Everything else after that, starts becoming repetition. We're just changing the connections. Let's go over to our very last one now.